Hi, this is Charlie. Excuse me, this is Charlie. Welcome to our next lecture on software engineering. Let me share my screen and we can get started. Okay, there's my screen. Let me minimize this. Okay, let's jump right into. So we're Module 5, Software Engineering. Please read Chapter 7 of the Bookshare book. There's some optional, I guess, reading that you can do here. A bunch of links there you can go to if you want. It might be helpful. Uh, and then there'll be a quiz, there's an assignment, and a discussion, similar to all the other weeks. Okay, so let's go to the lecture. Okay, Chapter 7, Software Engineering. Okay, we're going to cover software engineering design principles, the life cycle, software life cycle, software engineering methodologies, modularity, tools of the trade, quality assurance, right? The human machine interface, we could talk about documentation, software ownership, and liability. So we have quite a different topics that we are going to cover. The software engineering discipline, it's distinct from other engineering fields. It's the lack of prefabricated components, lack of measurements, right? And there's practitioners versus theoreticians. Um, And you should be aware of these organizations, the ACM, the Association for Computer Machinery, the IEEE, the Institute of Electronics, Electrical Engineering, right? These are our two major computer science organizations. There are other ones, okay, but these are the two major ones. Uh, and they help establish a code of professional ethics and standards, right? So let me move on. We're going to talk about here computer aided software and engineering, case tools. These are tools that help you in the software development. Okay, so they help you with project planning, right? Planning the project management, and they help you with managing the project. Okay, so for example, project planning could be how many weeks is it going to take to complete the project, to complete the software project, what resources we're going to need, and so forth. Now, project management is managing. Maybe it's managing the milestones, the important dates of the project, for example. And of course, there's documentation. We love documentation. So part of software engineering is not only writing the software, but it's also producing the documentation. It could be functional specifications, it could be design documents, and so forth. So documentation is important. Prototyping and simulation. That's another important topic. Uh, so maybe you going to present to a customer, you're suggesting this full blown out piece of a solution, and you're describing it. So maybe when you first come to the customer with the idea for the software, maybe you prototype it, you do a little bit of it and show how what it would look like and what would and how the software would function, right? Interface design. Interface design is very important, right? You need a usable interface, one that the users enjoy using. If it's a cumbersome interface, they won't want to use the solution, plain and simple. And actually, pro tools, these tool programming tools help you program. And recently, you have these LLMs, for example, ChatGPT. I think there's something called Codex, which I haven't fooled around with yet, and they can help you write the software, right? So, and that I think that's the latest thing, so that you can become more effective and efficient in writing the software. Of course, though, you need to audit that software. Okay, it may give you the code, spit you out the code, but you should look at it. You should look it over because I have experimented with ChatGPT and generating code. It's pretty good, but sometimes it gives you the code that you didn't want, or sometimes it doesn't really satisfy what you're asking for it in code. Okay, maybe towards the end I'll go into ChatGPT and show this. Actually, let me do it right now. So, and I think they're calling this vibe coding. So I don't know why I just here. I hate when always gotta. I don't know. So maybe I need a script that'll sort 10 numbers. Okay, as you can see here, here's the Python code. So for I in 1 to 10, enter. So this allows you to enter the numbers, right? And then there it calls the sort routine and displays the sorted numbers. So there's what I'm talking about, that you can interface with the LM to help you develop your code. Back in the day when I was coding, I do have to admit that you never really wrote code from scratch. You copied it. Maybe it was Google. You searched for Google for something similar that you had to do, and you would copy it and modify it. Or maybe, or maybe if you're working on a large software system and you had to make some modifications to it or make some additional code to it to give it some additional features, you would search in that system for code that was similar to what you need to do and copy and paste it and modify it. So what I think this does is this type of, we'll call it vibe coding. I think it takes it to the next level. It's more efficient, more effective. But what you have to be wary of is it may not give you exactly what you asked for. Okay. So therefore you have to audit the code. It's very important. You have to be able to read the code. So therefore, I think, of course, the skill of interacting with the LLM, the vibe coding, ask it the question that you need to get the code. That's a skill. And then another skill that's going to be very important is now that you have the code, you have to audit that code to make sure it's satisfying your requirements, right? So that's it. So maybe actually writing the code from scratch is a skill maybe that's going to become less important, maybe. And these other skills become more important. Okay, so let's move on. The software lifecycle, that's where we're on next, right? Yes, okay. Efforts put into the development of software can make a tremendous difference when modifications are required, right? So when they're talking, and then unlike manufactured products, maintenance consists of correcting and updating, right? Ongoing maintenance requires that someone can understand the program and its documentation. That's why the uh, documentation is important to understand the program. And if you come back to this, come back to the ChatGPT, which is nice, right? So here, which is very nice, is that can save you some time. Of course, you could do this with C, C++, or any language. It's very good at putting comments in the code, believe it or not. And it's very good in putting error checks in. There wouldn't be no error checks because this is very simple code. But I don't hear folks talk about this too much about the LLMs. But I've been bragging about them is that the actual error checking that it puts in is so good. Let's see this. Let's see here. So what I'm talking about here. Okay, so what's nice here is, okay, so I have the comments. Here it opens the file, it reads the file, it does the split, that splits up into words. I get the count, it prints out the number of words in the file. It's very nice here. Here's the error handling. So file not found error, right? So I got an error for the file not found. And here's an error checking for unexpected errors. So that's nice. You're getting error checking. And you'll see that if you want to put in, do some C coding or whatever language that you put in, the actual error checking is pretty good. Um, I find that lacking all the years that I was a C programmer for Bell Laboratories back in the day is that was, I tell you, that was really lacking was the error checking and the comments in the code. And that now you can get nice comments and error checking. I probably wouldn't write any code unless I pass it through an LLM to help me with the error checking and help me with the commenting. So that's just me. Okay, you understand the program. See, it's nice to LM if you don't understand what the program does, you could put the program in. For example, you can say, here's this program, what does it do? And it'll analyze it for you. So here's the software life cycle. There's development, right? So you develop it, you use it, and there's always maintenance, right? There's always different versions of software. There's always changes to it. Maybe more functionality wants to be added to the solution, or maybe there was a bug in the solution that needs to be fixed. For whatever the reason is, you develop it, you use it, and then there's a maintenance phase, right? Then you do maintenance and you schedule the maintenance. Okay, the development phase of the software life cycle. So there's requirements analysis. So kind of you have to gather what are we asking the solution to do? What are its requirements? And that's an art in itself, producing a requirements document, okay? And then there's design, right? You design, there'll be a design document maybe that would design the software and how did we design it. And then the next phase they move it implementation. You actually do the coding, you implement the coding. And then there's testing, right? So you test the software. Okay. And like I said, like I showed just with ChatGPT, I think the LLMs are going to be embedded in uh, each stage in this process. Okay. They think they can help you a lot. They can help you with your requirements analysis. They can help you. How should I design this? And how do I implement it? And then it can uh, testing, for example. So let's take the testing. So if you ask us, how can I test this? Right. So if you want to do testing, let's see what it says here. You can test it with a simple text file. Here's a step-by-step way to try it. Open a text editor. This is sample text. Save the file. Save the Python. Run the script. Enter the file name. See the result. Try additional tests. Empty file. So now it's telling you empty file. Create an empty file. That doesn't it? Large text. Let's pay. So it's giving you a bunch of helping you with the testing. Now I've used successfully the LLMs, specifically ChatGPT. It's helped me to test uh, my defensive monitoring detections. I use it. Uh, I've been working a lot in Sims and trying to detect malicious activity based upon the logs that they're gathering. And I worked with the ChatGPT to help me develop the detections, as well as how do I test false and negative cases for those detection. It worked great. So I do think this is the future. I'm not even sure if it's in the book because this is kind of new. If it's not in the book, then you heard it here first. Okay, so I don't think you'll be tested on this, the LM part. Requirement analysis phase, right? The requirements, application oriented, right? What is the application? What's it going to do? What are our requirements? Specifications. Specifications are technically oriented, right? What is our specifications? What we're going to use program, what the database structure is going to look like, what the web interface will look like, stuff like that. Software requirements document, right? and the software requirements document. Design stage, methodologies and tools. So what you know, there again, I was showing the design it. Maybe we're using an LLM, and there's a case tools, a whole bunch of other tools. Maybe using uh, Microsoft's development tools, right? Human interface, psychology and ergonomics, right? What is uh, human interface, right? We got to make sure that the humans can interface with the software properly. Uh, solution, okay? Implementation stage. Create system from design, write programs, create data files, develop databases. And like I said, there's going to be more and more integration with these LLMs into the design tools. It's already happening. That will help you become more effective, more efficient, because we're always under the gun. We always want this solution yesterday with less people, with no bugs, right? That's they're always pushing that envelope. So, and that's a way to try to help you with the LM. Role of software analyst versus programmer, right? There's a roles that you play. The program actually writes the code, and maybe the software analyst analyzes how the code is performing, right? So and again, this all depends on the size of your team. The more resources that you have, the more money you can throw at the solution, the more people you have, the more you can segregate the duties. The less people, then the more hats you have to wear, so to speak, right? The more you have to do. Mhm. Testing stage, validate testing, confirm the system meets specifications. Defect testing, find bugs, right? And so the testing is very important. Um, and we see all the time in the news software that fails, blows up, crashes because it wasn't tested properly. Sometimes not so easy to test. Software engineer methodology. Here's the waterfall life cycle method. Okay, follows the specifications, design, coding, implementation. Just like a waterfall, then go to production and then make changes and come back up to the specifications. Hopefully, we have a picture of this. Incremental model, prototyping, evolutionary versus throwaway. There's open source development. That's a big one. There's a lot of open source uh, software that's written open source, right? So that's important. And agile methods, right? So this is a method to develop software. And they're all described in the book. Modularity, functions, imperative paradigm, right? Structured charts, right? So you have functions, modularity, break things up into functions. Objects, if you do an object-oriented programming. Components, and there's a component architecture. A simple structure chart. Here's a control game. You have so I guess we're talking about maybe tennis or ping pong. Control the game. So this top box here controls the game, allows a serve, a return, compute the path, update the score, right? So it could be a video game. Okay, here's a structure of player chess and its instances. So we have a class, this is object oriented now. We have a class called player chess and the attributes, skill and endurance, right? So, uh, and the method serve and return volley. So player A is an instance of player class and player B is an instance. They may have different skill levels. They may have different endurance levels. Okay. Okay, here's an interaction between the objects resulting from player A serve. So player A, starting from the left here, player A executes a serve. And then the judge. So I guess the judge maybe would say, did it evaluate the serve? Was it in the serve? Yes. Judge, return volley. So then it'll send a message to player B, say, return the volley, right? And then player B will return the volley and it'll evaluate the return. And then player A evaluates serves. update score. So there's an example of the flow. That is a little confusing, but hopefully you get the idea. Structured chart including data coupling. Okay, so here's the game serves, returns, compute the path, update the score. And if you notice here, we have the two arrows here to the left, the player ID and the trajectory of the serve. What player is doing the serve, and then the trajectory of the serve is returned. And is that, I want to see something up here. So we don't have that. I didn't use that. So this is actually a poor example. Okay. Coupling versus cohesion. Coupling, control coupling, data coupling. Uh, so that's the coupling. So you have the what they talk about the data coupling again, the player ID from the serve and the trajectory. And so the coupling versus cohesion. Cohesion is logical cohesion, functional cohesion. So the best way I remember it is coupling is with the data, cohesion is with the functions, the logic. Logical and functional cohesion with an object. Okay, so here an object is only logically cohesive if here's a object, perform action A. Each method within this object is functionally cohesive. Perform function B, perform action C. Perform actions, I mean, A, B, and C. So these are actions that they can perform, the object can perform. Tools of the trade, and there's a lot of them. Data flow diagrams, so you can see the flow to data. Entity relationship diagram. One to one to many to many relations. And there's a data dictionary. So what we're talking about is uh, documenting and try to understand the data with these tools, okay? Now, one thing I comment on too is previous in the course, we used to do a group project where groups of maybe 4 or 5 would have to document this kind of stuff for a solution. But we have taken that away, and you can thank me later because group projects, me personally, I hate group projects, and I think they're additionally hard to do when you're remote and not in class together. I think the project becomes very difficult to do, and so we did away with that. And so I think some of this uh, you'll learn now through the lecture and reading the book, but then I'm not sure if you'll be questioned on it in the quiz, and the actual homework assignment won't require any of this. But this was required previously in the course, and it's good to know. Okay, here's a data flow diagram. A patient makes a payment. So then the payment is processed. And so the hospital updates the record, and then the patient record is updated, right? So, and then patient records, here's our processing patient records, process bills, and sends the bill to the patient. So we're talking about sending the bills to the patient and the patient paying the bills. Here's a simple use case diagram. Okay, a physician and a nurse. Hospital record system. So a physician can retrieve medical records, right? He has to be able to retrieve them to help to work with the patient. He has to update medical records. So if he sees a patient, he has to update the medical record. And he may need the laboratory results. So here the nurse on the right can retrieve medical records and update medical records, but the nurse doesn't have permissions to retrieve the laboratory results. Now here's an administrator. Administrator can retrieve financial records and update financial records, but the laboratory technician can only update the laboratory results. That makes sense. So if you're a laboratory technician, you would have no reason to retrieve financial records, right? So this all makes sense to me. Segregation of duties. A simple class diagram. A physician cares for a patient. One physician, that's what the number one says. One physician cares for many patients. That's what the asterisk is for. Uh, and 0 1 patients occupies one room. Okay. So a room can only have one patient. And the room hosts a patient. Okay. A unified modeling language, use case diagram, use cases, actors, class diagram. So there's use case diagram. And there's even in security, which we probably are not going to cover, is the misuse case diagram where they try to produce diagrams of how the system could be misused and then try to prevent that from happening, right? So you have the actors and use cases and you have class diagram. Okay, so here we have one to many, and many to many relationships between entities of types X and Y. Okay, here's a one to one, just one arrow to one. So one to many on the left, if you notice to the right, there are uh, two and three. So one to three, that's one to many. And there's many to many. This gets very complicated, right? When you have many to many, when you have all these lines crisscrossing. And there's a theory, I forget the name of it in software engineering, that the more areas you have in your diagram, the more complex it is, right? So in this case, there are a lot of areas, 1, 2, 3, 4, 5, 6. Whereas if you're here, you see 1, 2, 3, 4. So this is a much more complex system to work with and to test and so forth and develop. A class diagram depicting generalization. So here's a medical record. So of course you have the data record, the patient and the doctor, and the print record. So surgical record. Okay. Uh, so the reason why they're showing this is you have the surgical procedure, you have the hospital, data discharge, discharge patient, and print record. So it'll print the record. It's using the print record from the medical record for the surgical record. Same thing for office visit record. Symptoms and diagnosis, those are unique attributes to office record, but print record is right here shared from the medical record. So in object-oriented programming, that could be the same method, or it could be a method that it inherits and modifies slightly. Okay, that's object-oriented programming. Here we are back to this, a sequence diagram depicting a generic volley. Oh, isn't this so? Evaluate the serve, the judge, and there's a loop. You guys can read through this. I think you get the idea. I'm not going to go through this. Design patterns, well-designed templates for solving uh, recurring problem examples. Adapter pattern, used to adapt the module's interface to current needs. Decorator pattern, used to control the complexity involved with many different combinations of the same activities required. Inspired by the work by Christopher Alexander in architecture. Okay. Simulating a system. Sometimes you want to simulate it, right? For structured walkthroughs. Each member of the design team is given a CRC card class responsibility, uh, collaboration, theoretical experiment, role playing. I remember the very first simulation I wrote, and that was in high school many years ago. Uh, it was a crazy problem. I wrote it in C programming language, and we had a drunk on a bridge. He was on the middle of the bridge, and there was like 5 steps to the right. You could take him 5 steps to the left. And we had to use a random number generator. And so if the number was between, let's say we did a random number 1 to 10. If the number is 1 to 5, he took a step to the left. And if the random number that generates greater than 6, he took a step to the right. And then we portrayed him, the steps he was taking across the bridge. Crazy simulation. Quality assurance. Okay, this is important. Quality assurance. You want to see if the software does what it says, what it's supposed to do, right? So glass box te testing. So glass box means you could see, you know what the code does, and you base your testing upon it. There's something called the Pareto principle and basic path testing. Now there's black box testing. There's like a black box. You can't see it inside of it. You don't know the code. Okay. So boundary value analysis, redundancy testing, and beta testing. And of course, they've got all kinds of tools for this. And again, the LLMs help greatly with this as well. Documentation. We talk about documentation. User documentation. That's important for the users, right? Well, printed book for all customers. Do we really do that anymore? Not so much, I don't think. Online help modules. Yes, it's usually online, the help. Okay. Usually you don't get a printed book. Years ago, you got printed books. System documentation. The source code is documented in the design documents, right? So you have design documents. And there's technical documentation for installing, customizing, updating whatever the software. Again, that's usually online. I don't give you a book anymore. Not usually. Maybe sometimes, but it's not usual. They, or they may give you the material on a DVD or something like that, or it's just online. The human machine interface. Idea that software is a tool which is designed for the maintenance of the human using it. Ergonomics, physical abilities of humans, right? So cognitives, mental abilities, so habits and attention. So and we see this all the time. We know this that let's say you're an Amazon and you're buying stuff. It's adjusting to what you're buying and trying to get you to buy more similar stuff, right? And I think the social media sites are that way too. They're adjusting to what you're doing, right? Um, it's kind of a big deal. A software ownership and liability, copyright, right? So allow product to be released while retaining ownership of intellectual property. So uh, it's the copyright is it's very important. I have a crazy story to tell about this. Okay, so I was a contractor for the U.S. military, the Army, and they had SAP, German ERP systems. In other words, it had manufacturing pre-configured. It had accounts payable, accounts receivable, inventory, and all these modules, right? So, but they wanted change. The Army wanted needed changes to that original code, so they hired another company. Now that other company, when they changed the code, they put copyright statements in all the code that they owned the code, not the military. And then the U.S. military was very unhappy with the work they were getting from them, and they were very expensive. And they wanted to get rid of them. So the general said, "Get rid of them. We can do this cheaper and better with other companies." So they got rid of them, kicked them out. 3 days later, they were back. Why? Because all that software that they had written for several years was copyrighted. And so uh, kind of left the government in a bad spot, and so they had to bring them back. So if you're going to write code, it's a smart idea to copyright your code, so it's yours. And if you the other way, the other way, if you're paying someone to write the code, make sure it's yours at the end of the day, not somebody else's. Okay, assert it in all work, specification, source code, final project, final product. Intellectual property, software license, right? It's a legal agreement that grants the user certain permissions without transferring ownership, right? Intellectual property. Patents must demonstrate that it's new, usable, and not obvious to others with similar backgrounds if you want to get a patent. Process is expensive and time consuming. I don't have any patents. Okay, and so I do admit I do not find this subject to software engineering very interesting. I don't know if you do. But I find this one of the most boring modules in the course, my least enjoyable. This and the previous one with the website, make wheel on the website. So let's go to what I should have done. What do I hear? What do I have? Okay. Um, let's go to the assignment. Let's see what we have for assignment. The assignment. Okay. So consider the problem statement for an online auction system, right? So they give you a problem statement. So what this assignment really is, if you can understand the problem statements for the software, right? And then they're going to ask you, follow the ambiguities. None. So there is no specification when an auction gets over. So you got to see which ones you think fall within uh which is what are the ambiguities? Follow, and then what are the inconsistencies? So I think Uh, read it over a couple of times. Um, try to answer these questions. Try to choose the right uh, options in here. Ultimately, if you're not sure, you could use ChatGPT, right? So you can put this in and ask it uh, what it thinks its ambiguities are. That's probably a good idea to do, okay? Because maybe you haven't done a lot of work with problem statements. And so a good idea, I think, would be to first try it yourself, right? Put it in, put the question in, put in the, ask it which ones are the ambiguities. I mean, you read it and then choose that. Choose ones you think, and then I would go back and I would put it in ChatGPT and I would ask it what it thought the ambiguities are and explain why, okay? And then see if you missed any. If you did, now you know why you missed them, and then select it. Uh, select them also for your answer. And just let me know you use ChatGPT. I don't mind this. This is a great way to learn, I think, and get better problem statements. So if you have any questions on this, please let me know. So this is the assignment. It seems to be it's in the very non-technical assignment. Okay, so there's really no work on the computer. You just got to read through these. Uh, and this is where it was adapted from. So that's the assignment. I really don't have anything else for tonight. I think uh what's the assignment after this? Okay, so we have the software. Okay, operating systems. I enjoy that much more. And then we have networking and then the final. I think you'll if you're a more of a technical type person, then you'll like the operating systems and the networking better. But if you're more of a theoretical and more into documentation and you're more into software engineering, then of course you'll like this module better. Each to their own. Okay, so that's all I have for tonight. Does anybody have any questions that are online? Going once, going twice, gone. Okay, so we're done for tonight. A shorter lecture. It'll give you a chance to catch up if you're behind any of the assignments, and it'll give you time to think about this assignment. So have a great night, everyone, and I look forward to the next lecture. Take care.